Okay, in activity 3, it looks like we're dealing with distance equals rate times time problem. It says a river steamer requires 3 hours to travel 24 miles upstream and 2 hours for the return trip downstream. So the steamer goes up 24 miles and then there's a return trip. So the return trip we assume is the same distance, 24 miles. Find the speed of the current and the speed of the steamer in still water. So we're looking for two things, speed of the current and speed of the steamer in still water as if there was no current. So choose variables. Let's say speed of the current is x and speed of the steamer is y because we're looking for two things. We're going to organize our thoughts in the dirt chart. Rate times time is equal to the distance. Keep that in mind. Going up, we know the distance is 24 miles up. That's what they told us. Coming back down, since nothing else was disclosed, we assume it comes back down the same way and covers 24 miles as well. They also clearly told us the time. It requires the steamer 3 hours to travel upstream. So for the upstream, the time is 3 hours. And then 2 hours for the return trip. So for the return downstream is 2 hours. Which makes sense because coming down the current, again, we said helps the steamer. So coming down is faster. Going up is slower because the current tries to slow it down or stop it. Fill in the table about the steamer. We have it almost done. Rate is left blank. I mean, I know if I say the distance divided by the time, I should get the speed as a fixed number, but that fixed number consists of two pieces because the speed of the current and the steamer are sort of involved. Going upstream, you've got the steamer and then you have the current that tries to slow it down. So it's the steamer rate minus the rate of the current. Coming downstream is faster, so they act in the same way together, and that's y plus x. Now, always remember it's sort of like the object plus or minus the affecting factor is how you want to think of it. The object should come first and then plus or minus what affects the object. In our case, the object was the steamer, the object's rate was the steamer's rate, so I put that first, and then I said minus the current that slows it down. Or the steamer, the object, plus the current x that helps it go faster. So if I had my role switch, if I call this y and I call this x, for adding them the order wouldn't matter, but be careful for subtracting the order does matter. So it's easy to think of it object plus or minus affecting factor, and then whatever variable you call it, the object will come first. Now write two equations about the steamer. Well, we know the first guy, rate times time is distance, so y minus x, rate times time, I'll put the 3 in the front, is distance. And we also have rate times time for the second guy equals the distance. So there is my system for the scenario. Solve your system. Well, solving my system might not be so bad if I just divide both sides by 3 in the first guy, and I take the second guy and I divide, instead of distributing, I'm going to divide both sides by 2 because I have 2 times that stuff, 3 times that stuff, so I might as well divide it out. I have y plus x equals 12. So here's my first simple equation, here's my second simple equation. And if I just use the elimination method, it looks like things work out nicely. Divide by 2, and y is equal to 10. So we got y is equal to 10. We also know y plus x is 12. So we can guess already what x is going to be. If I isolate for x, or if I just use the fact that their total is 12, one of them is 10, the other one has to be 2. But I have to answer the question. What did the question want? Find the speed of the current, which for us we called x, and find the speed of the steamer, which we called Y. So to answer the question, the steamer is going at 10 miles per hour and the current is moving at 2 miles per hour. There were two components to the overall speed of the movement. There was a steamer by itself. If we assume there was no current, it would be going at 10 miles per hour. However, there was a current of 2 miles per hour affecting it. So what really happened was, going up, it was 10 minus 2, it was actually going up at 8 miles per hour. And on its way down, when it was coming down, it was 10 plus 2, and it was going at 12 miles per hour. But it didn't ask us, like, if we do that 24 divided by 3, yes, we get an 8. That was the upstream current. Here we have 24 divided by 2, which is 12. Yes, that was the downstream current. However, we have to keep in mind the problem didn't ask for the upstream and downstream rate. It asked for the rate or the speed of the current by itself individually, and the speed or the rate of the steamer by itself individually. So each component was 10 and 2.